And so let's talk a little bit then about exponents, and you guys are dealing with some product rules and power rules for today. And the first one that we're going to go over is going to be this 8 to the n times a to the n, right? So we end up adding the exponents there. And so, as you guys said, right, this guy is going to end up being this, but I just want to pause for a minute and let's actually explore this just a bit more in detail, like why that actually is that we end up adding them. So let's just make up some example. I don't know, let's just say 2 to the third times, let's say 2 to the 7. Okay, so when we have something like this, what does 2 to the third mean?
2 times 2 times 2.
Kind of like the way you guys said it, instead of saying 8, right? It's really what this guy is saying is it's 2 times 2 times 2, right? It's this number times itself 3 times. Mm-hmm. And then so similarly, what does 2 to the 7 mean?
2 multiplied by itself.
Right, so 2 times 2 times 2, right? Again, so 4, 5, 6, 7. Did I do that? 2, 4, 6, 7. Okay. And we're multiplying them, right? I mean, that's the key thing that we're kind of doing here, right? It's still multiplication. So now that we end up multiplying these, if we have the same thing written a whole bunch of times, then this is really 2 to the what?
10th power.
7th in there, right? Because we have 10 of them, right? So it's 2 really times itself 10 times, which you could actually write as this right here. Okay, and this is really the reason why we just said we could go ahead and add those guys. That's kind of the little shortcut that we get. But the thing is that it's just multiplication. We keep multiplying all the way through. And they're calling this guy power rule A. And what this one is stating is we have a to the m. Oh, I could draw a better m than that. To the n. Okay, and do you guys recall what this is equal to?
Mm-hmm. It's where you multiply the exponents instead of adding them.
Okay, so you agree with that? Or we end up multiplying these guys. This guy's going to be a to the m times n. And again, just to illustrate that, I'll go ahead and just go the tedious route so we could kind of see, you know, where that's going. But if we have maybe something like, let's just say 2 squared cubed, right? So maybe something like this, okay? Now what this is saying is it's cubed, so I have this inside term how many times?
3 times.
3 times. 3 times, right? We have this guy once, right? We have, and I keep writing my exponent twos differently, but we pretty much have this, right? And then we could expand this a bit further, so this is going to end up giving us that's really 2 times 2. This guy will give us the same thing. And then this guy will do the same thing. And again, we're multiplying everything together, right? I mean, we don't really need those, but just to emphasize it. And so what we're doing here is pretty much have all of these guys, and we're getting up with 2 to the 6 right there. Okay. So it's repetitive addition, pretty much what we're doing, and that's what multiplication is, right? A fast way to just do repetitive addition. Mm-hmm. So shortcut, what we remember is just this product rule. Okay, that helps us out, and it's just key to make sure that we don't get those guys confused. And what they're calling power rule B, and this is actually, I'm going to just write multiplication there because it's actually power rule multiplication. But what they have is they have A, B, to the m, okay, and then do you guys recall what this is?
Yeah, that's where you just distribute it out to each one individually, so it'd be a to the m times b to the n.
Yeah. You agree with that?
Yeah.
Alright, so in this case, a to the m, b to the n, yeah, that's correct. So that's what that ends up giving us there. Okay, so let's try an example of this guy here. And again, in order to see where this comes from, we could, you know, do this whole tedious approach of just kind of expanding them out a little bit. Let's do an example of this one. Let's see if we could apply, this is probably a good one, 3x to the 4, okay? something like this. So what do you guys think would be the first step?
Oh, well, first distribute it out, so 3 to the 4.
Right, so we get 3 times, so to just write this format, that's really 3 to the
You're
4.
81 actually
X to the
4.
4th.
Right. And then again, as we said, it's a fairly small number, so to simplify it all the way, you would get something like that. Okay, so good, so you guys are pretty comfortable with that. So this power rule is, and then this is our quotient. So again, I'll just abbreviate that, but it's pretty much division. We have for multiplication, one for division, which is our quotients.
Is that the quotient rule? Is that what that is?
Yeah, it's pretty much power rule for quotients, right? Division. Which is going to be something like this over b, and the way they're stating it is going to be with m. Okay, so you guys recall what this one ends up being?
Same as
It
before.
applies to both.
Yeah.
The denominator and the denominator.
Right, so the denominator and the numerator, so I get a to the m and then b to the m. Okay, good. So let me write an example of one here. Oh, this is a good one. So how about something x over 3 quantity squared. Okay, so how would we write this one out?
X squared over 9.
X squared over, I'm just gonna go ahead and write, every single step here, but you're correct, x squared over 9 in that case. Okay, and again, it just goes to each one.